Hello, and welcome to another episode in our series, Networking for the Layman. Um, from the last video, we were talking about subnetting, and we subnetted based on network requirements. In this video, we are going to be doing subnetting based on host requirement. It's pretty much the same thing with what we've done earlier. It's just that in this case, there's a little twist. The rules are the same, but we apply it somewhat a little bit different. Okay, so let me write out the rules. Let's take our examples in a minute. So rules written, and you can see number one, determine the number of hosts per network and convert to binary. Two, reserve the bits in the subnet max and you find your increment. Use your increments to find your network reference. So example one, let's take this class C example, uh, 216.21.5.0. For example, the class C network starts number 4, and we want 30 hosts per network. Okay, so I'm gonna clean that. Let me write it somewhere where I can keep it. I have very little real estate here. Submitting part two. So I'm changing 216.21.5.0 slash 24, and I want 30 hosts per network. 30 hosts per network. So first, rule number one, determine the number of hosts per network and convert to binary, which is what we have done. Converting 30 to binary will give us this. Start from here. I'm not really particular about the figure in binary. I just want the number of bits. 1, 2, 3, 4, 5. 5 bits. So my default subnet max is what? 255.255.255.0, which is 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So my rule number 2 says reserve the bit in the subnet max. This is supposed to be a K. I keep on making one mistake. The other time I spelled your without the O. Okay, reserve the bit in the subnet mask and find your increment. Okay, now this is where the twist is. When we're subnetting based on network requirements, that is based on how many networks you want to create. We were borrowing the bits. We're turning zeros to one. Now, in this case, what we're going to be doing is we're going to be saving zeros. That means my new subnet max is now going to be 255. I'm writing all ones. 255 dot 255 dot. I'm going to count from the back this time. Right? I'm going to count from the back this time and save 5 zeros. 1, 2, 3, 4, 5. Then turn remaining on. 1, 2, 3. Did you get that? When I'm subnetting based on host requirement, I am saving the host. Saving the host from back. But if I was subnetting based on the network requirements, I was coming from the front and reserving the turning zeros to 1. But in this case, because I'm subnetting based on network on host requirement, I am saving the bits. 5 bits. 1, 2, 3, 4, 5. I have saved. Of course, you know what that your increment is this, your lowest turned on bit, which in this case is what, 32, right? Which in this case is 32. So my increment is what? 32. So use your increment to find your network ranges. Starting from the first network, 216.21.5.0. I borrowed here, it was in the third octet here that I worked. So I will start adding in the third octet 216.21.5.32, 216.21.5.64, 216.21.5.32 plus, see, that's 696, and on and on. My network ranges are going to be 216.21.5.31. That's the last address before 32. That's 216.21.5.63, 216.21.5.95, and on and on and on and on. Of course, these are going to be slash words. 24, 25, 26, 27, all slash 27 networks. If you don't understand what I just did here, how I'm able to convert binary to decimal, decimal to binary using this chart around here, using this chart, you should see our video on IP addressing. Alright, now that is a pretty straightforward example. I believe you understand. Let me see the second scenario where we can create, where we can use another example. Okay, another example is this. I'm having 195.5.6.0 in a class C environment. I want you to divide it such that we'll have 60 hosts per network, 50 hosts per network. Okay, rule number 1, 50 in binary. First, it starts from here. So how many bits are we going to be using? 1, 2, 3, 4, 5, 6 bits. Okay, reserve bits in your subnet max, which is going to be 255.255.255. I'm saving 6 bits. 1, 2, 3, 4, 5, 6, 7, 8. Alright, yeah. So my new subnet max, my increment is what? 128.64. So my increment here is 64. Yeah, I'm doing some brain work, some calculation. I'm not writing down because I believe by now we should be past this level. We've done it quite a couple of times, both in the last video and in this video. So my increment here is 64. So if I'm going to write for my new subnet max out, it's going to 255.255.255 dot that should be 128. 192. That should be 192. 192. That should be 128 plus 64 should be 192. Yeah. Okay, that is a slash what? 24, 25, 26 is slash 26 network. Okay, so I have all the pieces. I'm gonna write out my networks. 192 1 sorry 195.5.6.0, 195.5.6 dot, what is my increment? 64. 195.5.6 64 plus 64, 128. Okay, that should be about it. The next one should be 250. 64 plus 128. This should be 2. 6 plus 2, 1, 8. Carry 1. So 1, 9. 192. 1, 6. 195 dot 5 dot 6 dot 192. Then 195 dot 5 dot 6 dot 256. And you know we can't have 256, right? We can't have 256. Okay, so ranges is 195 dot 5 dot 6 dot 63. I'm just going to just write the ending ranges so that we don't save on time. So that will be 2 dot 63, 195 blah 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 blah, 2 dot 127, 2 dot 191, and 2 dot 255. Yes, I'm good. Okay, so all these are going to be what slash 26 slash 26 networks slash 26 slash 26. Now you can see it's pretty much straightforward. In subnetting with respect to network requirements, we move from the left to the right. But in subnetting based on those requirements, we move from the right, save the zeros, back to the left. Alright? So this is pretty much straightforward. I'm going to give you one or two more examples, and I want you to drop the results in the comments on my YouTube page where this video will be posted. Um, Pretty much, let me take a class B example. I'll leave you with a class A example. I'll leave you with a class A example, but let me do a class B example for you. Okay, class B example 155.00 to 500 ohms per network. So row 1 determine 500. If I turn everything in here on, this will give me a 255. So I don't have 500. If I had everything here, I won't get 500. So what do we do? Yeah, it's pretty much straightforward. You can extend this. 128 should give us, so this 2 raised to the power 7, 2 raised to the power 8 should give us what? 256. 256. The next one should be 512. Then 1024. Then 2048. Alright? But I'm going to leave it at 256 for now. 512. Of course, I can't get what's it called here, 500 from here. It's way more than 500. So that means I'm going to start from here. So how many bits am I going to save? Am I going to be using? You guess right. 9 bits, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bits. So now that I've determined that, should I give you this as an assignment? Okay, now that I've determined that the first subnet max is what? 255.255.0.0. So I'm going to save 9 bits from here. That is the whole of this is 8 plus 1 here. Alright, so my new subnet max is going to be what? 255.255. Now I'm going to save 8. 1, 2, 3, 4, 5, 6, 7, 8. Dot 9. Are we? That I've saved 9 bits. Turn the remaining up. 3, 4, 5, 6, 7. Okay, so this is my new subnet max, which is going to be what? 16, 17, 18, 19, 20, 21, 22, 23. Excuse me. Which is going to be a slash 23 network, or 255.255.252.0. You remember this from our last example? Okay, now that I've done this, my increment is going to be what? My lowest one, which in this case is what? 2. With all these pieces, I can get my network ranges. My network ranges are going to be what? 150.5.0.0. This is going to be dicey. Where is the increment? Where was the last place I got from? It was from here. So I'm going to add it in the third octet. 5.2.0, 150.5.4.0, 150.5.6.0, 150.5.8.0, and you know what's 1.255, 3.255, 5.255. You get the whole idea. Yeah, you get the whole idea. 7.255. I only dropped the leading 150.5.7.255. 150.5. You get, you understand. I believe you understand. So these are my network ranges, all slash 23 networks, and they are guaranteed to have at least at least 500 hosts per network. Can accommodate 500 hosts per network. For clarity's sake, you might want to do a little bit. How many hosts per network do we want here? That's 2 raised to power n minus 2, where n is what? 9, right? In this case, n is our number of our host bits. Our host bits. So 2 raised to power 9, 2 raised to power 7, 2 raised to power 8. 2 raised to power 9 is 512. That will be 512 minus 2. This minus 2 being the first address and the last address, the host address and the network address and the broadcast address. So we are not going to use that. So this, we are going to have 510 valid hosts per each network. Yeah. Does it take care of what we want to do? Yes, it does. It takes 500 hosts per network. Alright, so I think this is cool. We I can drop some assignments for you now. Work on your own. Get examples. If you want examples, you can contact me. I can send you some more assignments where you can work on your own and hone your skills in subnetting. The next topic we're going to be talking about is variable length subnet max, which is an offshoot of subnetting. Just we just wait for the next video. It's gonna be out very soon. Um, I'm true. Let me drop the assignment for you, and I'll sign off. Okay, these are my assignments. You can go through them, practice on your own, create some on your own. Go online, look for sample questions, something like this, and do. If you run into any problem, just contact me. You have my contact. It's going to be in the bio for this video on YouTube. Thank you very much for viewing, and I hope this has been very informative.